Okay, derivative trig functions. Now, as much as I'm not a fan of memorization, you've heard me say that 1,000 times, I do have a couple things that you're going to have to memorize. So we're going to talk about all 6 trig functions and their derivatives. It's not that bad, really. We're going to talk a little bit about harmonic motion, not too much today. We'll get to it later. And then thank somebody for something today. Okay, good. All right, so here's the first thing. I could take you through the derivative it's going to seem like I'm being redundant. I could take you through the derivative of the origin of the derivative of the sine and the cosine, but it's not worth our time. It's really ugly, and I would lose half of you about a quarter of the way in. So, in that case, you just got to memorize those. Okay. Derivative of sine is cosine, and derivative of cosine is negative sine. Now, a couple things that'll help you when we get to all 6 of them is that if you start with a function, okay, so hopefully you've been taught this at some point. There are 6 trig functions that we deal with, yes? 3 of them are functions, 3 of them are co-functions. Did you know that? What are the functions? Sine? No. The functions are sine, secant, and tangent. Then we have the 3 co-functions. Cosine, cotangent, cosecant. Okay? So the way to remember this is that when you're dealing with the co-functions, they get minus signs. It'll make more sense as we work our way through the slideshow. If you know this, then we can find all the others. Like, let's say, for instance, I wanted to know the derivative of tangent. Other than looking it up, how would you go about taking the derivative of the tangent?
Derivative of the sine, derivative, or we do quotient rule.
Quotient rule, correct. We would do sine x over cosine x, and then take the derivative of that, which would be cosine squared x on the bottom, cosine up on top. Derivative of sine is cosine, minus big honking bracket, the numerator, times the derivative of the denominator. Do you see where this is going? Luke, your hair's different.
Yes.
Went a little darker for the fall.
Mm-hmm.
Like it.
Thank you.
It's not quite black, though.
It was about 2 days ago.
So you washed more of the color out?
It's been slowly lightening.
I understand. What's the numerator become? One, right? Cosine squared plus sine squared. That's one of the few trig identities that you need to remember from pre-calc. Okay. Cosine squared plus sine squared is equal to 1, so this becomes this, also known as secant squared. Now, does that mean every time you're going to take the derivative of tangent, you're going to go through this quotient rule? Absolutely not. You're just going to remember that the derivative of tangent is secant squared. But this is where it comes from. And we could do that with cotangent, and we can do that with secant, and we can do that with cosecant, or we could just do this and get to a chart. Oh, there's all, I forgot I did the work. There you go. Okay, notice the co-functions, cosine, cosecant, and cotangent have minus signs on them. So when I'm working with this, what I do is I just memorize the functions and their derivatives, and then I can figure out the co-function derivatives based on the minus sign and the co-functions. Does that make sense? Compare these two. If I know the derivative of secant is secant tangent, then I know the derivative of cosecant is the opposite of their co-functions, cosecant, cotangent. Now, some of you are just going to memorize all 6. That's fine. Whatever works for you. And the bare minimum, you need to memorize the sine and the cosine, because we're not going to do the derivative of that. The derivation of those derivatives. Got them? Good? Okay. Then the fun starts. If you know the derivatives of the trig functions, then we can start incorporating the derivatives of the trig functions into other things we've done, like, for instance, product rule. 2x plus 3 times the derivative of cosine. Well, it's a cofunction, so I'm going to minus in there, and that's going to be sine of x. Boom. Plus x squared plus, no, I did that wrong. Sorry, had too much caffeine. That's a cosine there. Then I get the x squared plus 3x times negative sine x. Be aware of my parentheses there. Don't write it as x squared minus 3x minus sine x without parentheses, because otherwise it becomes a minus sign. Could we multiply that out? Yes. Will it do us any good? No. Done. Okay. So there's nothing new there except taking the derivative of the cosine, which again we got from that chart. Am I going too fast or are we good? Good. It's not rocket science, so you should be okay. Ooh, tangent lines. What are the two things you need for the equation of a line? Point and a slope. How do we find the point? Plug it in, right. What's the cosecant of pi over 2? Ooh, unit circle stuff. Why?
Because the sine of pi over 2 is 1, and 1 over 1 is still 1.
Okay, so our point is pi over 2 comma 1. How do I find the slope? Derivative. F prime of x is negative. What's the derivative of cosecant? Cosecant x, cotangent x. So then we need f prime of pi over 2. Negative 1 times the cotangent of pi over 2. It's reciprocal of the tangent of pi over 2, which is 0? Do that right? That would be x over y. So the x would be 0. Yeah, 0. Which equals, slope is 0. What does that tell you about the line? Horizontal. Right. Which is y equals 1. It happens to be a point on a graph with a horizontal tangent. Done. Told you it's quick.
That's funny.
Okay. Discard. Stop the recording.